Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is cyclohex-1N1-vial, acetylene, I1-ethinyl, cyclohex-1Na, which has a terminal alkyne -CCH attached to a cyclohexene ring at the double bond carbon. Moving on to the next step. 9H2 is a strong base that deprotonates the terminal alkyne to form a sodium acetylide, carbanion at the terminal carbon. This acetylide then undergoes SN2 alkylation with CH3Br to give the internal alkyne, cyclohex-1N1-vial, CCCH3. This is compound A. Moving on to the next step. Lindlar catalyst performs SYN selective partial hydrogenation of the internal alkyne to give a CIS-Z alkene. The triple bond, cyclohex-1N1-vial, CCCH3 is reduced to the CIS alkene, cyclohex-1N1-vial, CH is equal to CH, CH3 with Z, CIS, configuration, meaning both H atoms are on the same side of the double bond. And for the final step, the product is Z-cyclohex-1N1-vial, 1-propenyl, I, CIS-1,1-propenyl, cyclohex-1Na. In option C, the structure shows the cyclohexenyl group attached to C, H, is equal to C, H, with CH3 on the same side as H, CIS, consistent with Lindlar hydrogenation giving the Z-alkene. Why other options fail? Option A shows an internal alkyne with no reduction, which would be compound A, not B. Option B shows a trans E alkene, which would result from dissolving metal reduction, Na NH3, not Lindlar catalyst. Option D shows a vinyl group, no methyl, which would arise from a different starting material or reaction pathway. Therefore, the correct answer is C. Therefore, the correct answer is option C.